Today we're going to go back and revisit a topic that we did way back at the beginning of the year, which was radical equations, solving them for x, finding the value, the input that will make the equation be true. Now the main idea of this, first of all, is opposite operations. Opposite of square rooting is squaring. Opposite of adding is subtracting. Opposite of dividing is multiply, and so on. So looking at this first equation, radical 3x plus 4 equals 5. The radical is already all by itself. There's nothing else attached to it by adding, subtracting, multiplying, and divided. So we can get rid of the radical, the square root, by squaring the left side. But if I do that on the left, I have to do it on the right. So over on the right, 5 squared will make 25. And on the left, the square and the square root cancel each other out and just leave us the part underneath the radical. And now we've got this simple linear equation to solve. Subtract 4 from both sides. 25 take away 4 is 21. And then dividing both sides by 3, x equals 7. And I've also done a little check of this on my graphing calculator. There's the curve, radical 3x plus 4. The flat line, y equals 5, and you can see they intersect at x equals 7. Or I could also check by plugging that 7 into my original equation. 3 times 7 would make 21, plus 4 is 25, and the square root of 25 is indeed 5, so it does check. We're going back and revisiting this topic because when you're solving a radical equation, you can also end up in the process with a quadratic equation to solve. So like in this example here, I have the radical all by itself on the right. Now to get rid of that radical, I'm going to have to square both sides. And notice on the left now that x minus 1 squared really means I'm doing x minus 1 times x minus 1. And that's what's going to lead us to a quadratic equation to solve. On the right side, the square and the square root cancel out and leave me 15 minus 7x. So on the left, we're going to need to FOIL these or multiply these two binomials. X times x will be x squared. Outers and inners will make minus 2x. And the lasts will make positive 1. Equals 15 minus 7x. Now because this is a quadratic equation, we're going to need to make this equal to 0. So I'm going to add 7x and subtract 15 from both sides. Add 7x, subtract 15. So on the right, that'll give me a 0. And on the left here, we're going to keep the x squared. Minus 2x plus 7x is plus 5x. And positive 1 minus 15 is minus 14. Now at this point, when you have your quadratic equation equal to 0, you've got your choice here. You can complete the square, you can do quadratic formula, or we can try to factor in Mr. Squiggly. This, I believe, we are going to be able to factor it, so that'll probably be the easiest method. X and x in the front. Numbers that times to 14 and add or subtract to make 5. We could do 7 and 2. 7 is the bigger number, so it gets the plus sign from the 5. 2 will be a minus, and Mr. Squiggly comes along and says our two possible answers are x equals negative 7 or x equals 2. I'm going to do a little check of this on my calculator. So my x minus 1 is on the left, my square root of 15 minus 7x is on the right. When I graph, here they are. And notice my curve and my line are only intersecting in one spot there. Let's find that intersection spot. X equals positive 2. But notice my other supposed x value, negative 7, if we go over to negative 7, the curve and the line do not intersect there. So this negative 7 is what we call an extraneous solution. It does not check into our original equation. I'll show that in just a second. So let's take that 2 and plug it into our original equation. I have my 2's plugged in, and now we're just going to simplify both sides. 2 minus 1 is 1. Then I have got the square root of 15 minus 7 times 2, which is 15 minus 14 is 1. And the square root of 1 is indeed 1. So x equals 2 checks out as an answer. But watch what's going to happen when I use that other number, negative 7. On the left, negative 7 take away 1 is negative 8. And here we're going to have 15 minus 7 times negative 7, which is going to be 15 plus 49, which is 64. And the square root of 64 is 8, which does not equal negative 8. So we have an extraneous solution that we're going to ignore, and x equals 2 is the only answer. Here's an equation where the radical is not all by itself. We have a 3 attached to it with an add. So we're going to move the 3 away from the radical to get it all by itself by subtracting it. So that will leave us on the left, x minus 3. And on the right, we're going to have radical 29 minus 5x. And now this is the point at which we can get rid of the square root by squaring both sides. And again, here on the left, x minus 3 squared is not x squared plus 9. It is x minus 3 times x minus 3. And on the right, squaring the square root will cancel out and leave us 29 minus 5x. Over on the left, two binomials we're going to have to multiply or FOIL, which will be x squared minus 6x plus 9 equals 29 minus 5x. And again, we've got ourselves a quadratic equation, so we're going to have to make this equal to 0 by adding 5x to both sides and subtracting 29 from both sides. That'll give us our equals 0. And on the left, x squared, negative 6x plus 5x is negative 1x. And 9 and negative 29 is negative 20. And we're at the point where you now have your choice. Quadratic formula, complete the square, unfoil Mr. Squiggly. I think I'm good here again with unfoil Mr. Squiggly. X and x in the parentheses. 5 and 4 will multiply to 20, and we can make a negative 1 by negative 5, positive 4. And Mr. Squiggly says our two possible answers are x equals 5, x equals negative 4. And I'm going to use my calculator to check this. There's the left side and the right side of our original equation. Notice the curve and the line are only intersecting at one spot, and that spot is at x equals 5. So we have x equals 5 as our solution, and x equals negative 4 is an extraneous solution that we're going to throw out.